I worked on the default cancer cell detection project. This video has three main parts. First, I will talk about the pipeline, which includes the data, the model, and how the model is trained. Then I'll walk through the code, and finally, I'll show some example results. I used 21 slides from the dataset, and 14 of them are used for training, 4 are used for validation, and 3 are used for testing. The input patch is from level 0, and its surrounding context patches are from level 3 and level 7. I use data augmentation where the brightness, contrast, hue are adjusted randomly, and the patches are also flipped and rotated. The dataset has a batch size of 32, and I sample at most 256 patches from each slide. At most here means that I'll discard the patches that are completely gray. Because there are much fewer positive patches, after I sample those 256 patches from each slide, I will sample additional positive patches in the neighborhood of the positive patches that's already been sampled. The base of the model is Inception v3, but I only use the first 10 layers, because the paper suggests that they achieved similar performance using only 3% of the parameters. Because the input patches are from 3 levels, we have 3 patches as input. So we have 10 inception layers for each input patch, which means there are 3 independent inception towers, and the inception layers are connected to several dense layers, and the model has about 32 million parameters. The model is trained for 15 epochs, and I used a learning rate of 0.001. After 15 epochs, the training accuracy reached 98% and the validation accuracy reached 95%. The first plot is accuracy against epochs, and the second plot is loss against epochs. Now let's walk through the code. The first thing we want to do after we import those packages is to download the files from the dataset given the URLs. Then we want to extract patches from those files. There are some helper functions in this cell. But let's show some examples first. An input example consists of 3 patches. One patch from level 0, one from level 3, and one from level 7. After we extract those patches, we augment them. By changing their brightness, contrast, and hue randomly. We also flip the patches horizontally and vertically, and rotation is also used. Then the training, validation, and test sets are generated. The 3 data sets are split on the slide level, which means the first 14 slides are used for training. The other 4 slides are used for validation, and the remaining 3 slides are used for testing. And as you can see here, the training set is balanced, where there are 52% of the training set are positive. Then we define the model. So for each input, we have an independent inception tower, whose output was passed to a dense layer, and the 3 dense layer outputs are concatenated. before they're fed into a common dense layer, and then the final dense layer is used for classification, which only has one unit. This model has about 32 million parameters. And here's a plot of the architecture. The models are saved to checkpoints. As in assignment 4, we defined the checkpoint path here. Then here is the training loop for the model. The model reached a training accuracy to 98% and the validation accuracy to 95%. Then we plot the training history. Finally, we test the model on the remaining 3 slides. The model has a test accuracy of 96%. The recall is 92%, and the precision is 90%, and the F1 score is about 91%. Here we print the true labels and the predicted labels in order to check whether the model is predicting all 0. Then here's the function for comparing the true and predicted heat maps. And we show the result for the 3 slides in the test set. The high recall here is reflected on the heat maps because the predicted heat map covers most of the true heat map. But here are some false positives in the center, which is reflected in the precision. Just to repeat the test result from the Jupyter notebook. Here is the heat map comparison of the tumor 96 slide. The precision and recall are relatively low on this slide. On tumor 101, the precision is relatively low because it's producing a lot of false positives, but the recall is about 88%. And here is the result for the tumor 110 slide, which is shown in the code walkthrough. Thank you very much.